Whole wheat bread has a higher glycemic index than table sugar. The fiber that was supposed to make it healthy is simultaneously binding the zinc, calcium, magnesium, and iron you needed from it, and blocking their absorption entirely. That is not a fringe claim. That is the finding of a meta-analysis of 13 controlled studies, and it means that the single most common dietary upgrade people make when they decide to eat healthier produces no meaningful improvement in blood sugar response and actively reduces mineral absorption in the process. Today, we are going inside exactly why that is, why every other loaf in the bread aisle is built on the same flawed foundation, and how 5 specific ingredients assembled in a specific order produce a loaf that does none of those things. Before we go further, think about the last time you chose whole wheat over white because you thought it was the healthier option. What if the choice was between 2 versions of the same problem, and the real alternative was something the bread aisle does not carry at all? The glycemic index of table sugar is 65. The average glycemic index of whole wheat bread, derived from a meta-analysis of 13 studies published in the American Journal of Clinical Nutrition in 2008, is 71. Not similar to table sugar, higher. 2 slices of the bread millions of people eat every morning spikes blood sugar faster than a teaspoon of the substance they are trying to avoid. The fiber content does not prevent this. It slows gastric emptying slightly, but cannot neutralize the speed at which the dominant starch in modern wheat is cleaved into glucose by digestive enzymes. The starch structure is the problem, and fiber cannot restructure it. Then there is phytic acid. The bran layer that whole wheat retains, removed in white bread, contains phytic acid at concentrations that bind to zinc, calcium, magnesium, and iron, forming insoluble complexes that pass through the gut unabsorbed. A 2010 review in Food and Nutrition Research found that phytic acid in whole wheat bread reduced zinc bioavailability by up to 35%, and iron bioavailability by up to 40% compared to the same meal without it. A blood sugar spike with a mineral trap built into the crust. In the late 1950s, Norman Borlaug was working in a Mexican research field trying to solve one of the most urgent problems in human history: how to grow enough grain to feed a rapidly expanding global population. His semi-dwarf, high-yield wheat strain earned him the Nobel Peace Prize in 1970 and is credited with saving over 1 billion lives. The humanitarian achievement was genuine. The metabolic consequence went unexamined for decades. The hybridization process that produced high-yield modern wheat dramatically altered its starch composition. Ancient varieties like einkorn and emmer contain amylopectin B and C, forms that digest relatively slowly. Modern commercial wheat is dominated by amylopectin A, a highly branched starch that digestive enzymes disassemble almost completely within 20 to 30 minutes. Dr. William Davis, a cardiologist whose research informed his 2011 book, Wheat Belly, documented through continuous glucose monitoring that 2 slices of modern whole wheat bread produced blood glucose peaks indistinguishable from 2 tablespoons of pure sugar in the same subjects. The wheat that saved 1 billion lives and the wheat on your shelf are 2 different plants wearing the same name. No fiber changes the amylopectin A structure. No label neutralizes it. Every loaf in the bread aisle, whole wheat, white, multigrain, sourdough, ancient grain, gluten-free, is a variation on the same problem. They are all built from the starch of modern hybridized grain, and starch is what your digestive system converts to glucose, regardless of what surrounds it. Sourdough fermentation reduces the glycemic index modestly. A 2020 study in Foods found long-fermented sourdough averaged a glycemic index of 56, still a significant blood sugar event. Gluten-free bread replaces wheat starch with rice flour, tapioca, or potato starch, all with glycemic indices between 70 and 95, higher than the wheat they replaced. The gluten-free aisle solved one problem for one population and made the blood sugar problem worse for everyone else. The label changes. The metabolic outcome does not change enough to matter. The only genuine exit is a loaf built from ingredients that were never grain. If 5 ingredients produce a loaf that does not spike blood sugar and does not strip minerals, what is each one actually contributing? Almond flour is the base. Ground blanched almonds, approximately 20% protein, 50% fat, and 10% net carbohydrate, with the carbohydrate fraction consisting primarily of fiber rather than starch. No amylopectin A. Glycemic index estimated between 0 and 5. A 2011 study in metabolism found that replacing wheat flour with almond flour reduced postprandial blood glucose by 36% and insulin response by 38%. Butter slows digestion and delivers fat-soluble vitamins wheat bread cannot. Eggs are the structural protein network, the functional replacement for gluten. And psyllium husk is not a filler. It absorbs water, binds the dough, and feeds the gut bacteria most depleted by refined carbohydrate consumption. Each ingredient has a precise reason. None of them are substitutions. They are deliberate choices. In 1859, French chef Antonin Carême documented something his kitchen had discovered over decades. Egg whites, beaten to stiff peaks and folded carefully into a batter, could rise without leavening, hold their shape after baking, and collapse entirely if folded carelessly. He did not know the protein chemistry. He knew the outcome. What he had discovered was the functional behavior of ovalbumin, the primary protein in egg whites. When beaten, ovalbumin proteins unfold and form a network around air bubbles. Beaten to stiff peaks, the foam contains millions of microscopic air cells stabilized by that protein network. When heat is applied, the network sets permanently, exactly the structural role gluten plays in wheat bread. Without gluten, the whipped egg white foam is not an enhancement. It is the entire architecture of the loaf. A 2018 study in food hydrocolloids found that whipped egg white foam increased specific loaf volume by 47% and reduced crumb density by 39% compared to the same formulation using whole, unwhipped eggs. Skipping this step does not make the bread denser. It removes the structure that makes it bread. Stiff peaks, gentle fold. That is the recipe inside the recipe. Psyllium husk is listed as a binding agent in this recipe. It holds the dough together, absorbs water, and creates the sliceable texture. All of that is accurate, and none of it is the most important thing psyllium is doing. Psyllium is a prebiotic soluble fiber. When it reaches the colon undigested, it becomes a fermentation substrate for the bacterial species that refined carbohydrate consumption has most depleted. Bifidobacterium longum and Fecalibacterium prosnitzii, which produces butyrate, the primary fuel for colon epithelial cells and a key regulator of intestinal inflammation. A 2019 randomized controlled trial in the American Journal of Clinical Nutrition, following 132 adults over 12 weeks, found that daily psyllium supplementation significantly increased Bifidobacterium and Fecalibacterium populations and reduced inflammatory markers CRP and IL-6 compared to the control group. This loaf is not just avoiding the damage conventional bread causes. It is repairing the gut environment that conventional bread has spent years disrupting. The binding agent is also the repair agent. The bread aisle was not built for your metabolic health. It was built for shelf life, yield, and marketing. And the whole wheat label was applied after the agricultural hybridization and the phytic acid mineral trap were already baked in. Every loaf on that shelf is the same problem in a different package. 5 ingredients assembled in a specific order produce something the bread aisle cannot. A loaf that registers near 0 on a continuous glucose monitor. A binding agent that repairs the gut bacteria conventional bread spent years depleting. A structural network built from egg white protein that delivers the lift and texture wheat gluten was supposed to provide, without the amylopectin A that turns every slice into a blood sugar event. Make it once, and you will understand why the technique matters as much as the ingredients.